Tomorrow we're going to be doing the microscope lab. So today what we're going to do is we're going to do a review over the compound microscope. We use compound microscopes to observe things that are very small, such as cells. Cells can range in size from as small as 1 micrometer, which is 1/1,000,000th of a meter. Now if you think about that, that would be in 1 centimeter, you could put 10,000 micrometers. So that's just how teeny this is. And the cells that are that teeny are cells such as bacterial cells, because bacteria have teeny little cells. We'll talk more about that later, but let's go into the parts of the microscope so that you're familiar with what we'll be using tomorrow, and then we'll build on that of when you use what parts of this microscope. So the compound microscope has 2 sets of lenses, and the 2 sets of lenses is where the word compound comes from. If you think of a compound, you put things together, right? So the first, you have the eyepiece. And the eyepiece has a magnification of 10 times what you're actually seeing. So if you're seeing a penny, and that would be too large really to look under a compound microscope, but let's pretend, just for the sake of understanding just what the type of magnification we're talking about, it would make the penny appear 10 times larger than it actually is. So that's what you would be seeing. And then the eyepiece is supported by the objective lenses. And the objective lens, there's 3 parts to that. There is the low-powered there. And the low-powered lens gives you an additional magnification of 4 times the actual size of an object. Then you have the medium, and the medium gives you 10 times the actual size of the object, and then you have the high power, which by itself as a lens would give you 40 times the actual size of the object. However, remember I said it's compound. Well, since it's compound, what that means is the 10 times the eyepiece that you get in magnification from the eyepiece is multiplied, has a multiplicative effect with one of the objective lenses. So for instance, if you're looking through the low-powered lens, through the eyepiece, you are actually seeing something that is 10 times 4, or 40 times greater than its actual size. So you're able to see that level of detail. When you move that up to the medium level objective, then you're going 10 times 10, or its total magnification is 100 times. So what I'm doing is I'm taking 10, which is the eyepiece magnification, multiplied by the objective lens magnification, and resulting in the total magnification. Okay, so that is the total magnification right here. So the next part is if you're using the high-powered lens, and that's 10 times 40, which the maximum magnification we get with our compound microscopes that we use here at the school is 400 times magnification. So this is a really important thing to understand, because why do we use a microscope? Well, we use it to observe things and see the details, but we also understand just how small something is. So things of different sizes, we will have different base total magnification we will want to use. You don't want to, if something's a red blood cell, which is the smallest cell in the human body, you want to make sure that you're using the highest level of magnification so you can see the most amount of detail there. If you're seeing something larger, you may not need to go to the 400 times, because that might fill up the entire area that you're seeing, and you may have no ability to really see the outline of the object you're looking at. So you will need to make some judgment calls, and as we work in the lab, we'll be able to talk about, hey, when do I use this? When do I use that one? So this is the key part of the microscope. Now there are some other parts of the microscope that can help you get a clearer image as you're using the microscope. One is the light source. So beneath the stage, And then here we have the stage. Okay, beneath the stage, you're going to have a light source. And that light source is going to provide the necessary light to be able to see through the single cell flat slides that we're going to be looking at. And without that light, it's just dark and none of the outline that you want to see in the image on the slide is visible. So that's very important. And you can open up, there's an area where you can open up and close down the amount of light that comes through that makes the image that you get is better for what you're looking at. Then this here is, we have the coarse adjustment and the fine adjustment. These are also important parts that you'll be using on the microscope. As you're trying to find your cell on your slide, you will first use the low power, the 4 times, which in total is 40 times magnification, to locate whatever it is you're trying to find. Never start with the high-powered adjustment. If you start with the high-powered, you won't even be able, it's such a small area that you'll be looking at, it's very difficult to find the thing you're looking for. So after you start with the low-powered, you will use the coarse adjustment to just make sure that you have something that you're able to see underneath the eyepiece. Then, after you've located, oh, there's a cell, then we use the fine adjustment to focus that area. Do not continue using the coarse adjustment. If you continue to use the coarse adjustment, that coarse adjustment moves a platform up and down. It moves the actual stage in a very large way. Coarse meaning kind of large movements. And if it had that large movement, you can actually smash it into the lenses, break your slide, ruin your slide. So it's really important that you don't use the coarse adjustment for your total adjustment. Just at the beginning when you're just trying to find the object you're looking for underneath the microscope slide. Then you use the fine adjustment to get that focus. So when you do that, you are able to get the total best picture that you are able to see and really find the cells that you are looking for. And don't worry, when we do microscope work, it's always a little frustrating at first. Getting used to how do you put this on and use the right objectives and use all these tools. That's why we're talking about it right now, but even once we get there, it sometimes can take a little while to find the things you're looking for. Finally, some safety on how do we carry our microscopes. We need to carry our microscopes, I'm sure we heard this in middle school as well, with 2 hands. One hand is going to be on the base, and the other on the arm. Okay? So you hold it by the arm and the base whenever we're carrying it around the room. And that's really important because these are very expensive tools. We need to make sure we take really good care of them so that classes in the future can use them as well. And we'll be using them later in this class, not just for this lab. So this is the compound microscope. We will be using it to look at cells. I will be talking to you a bit tomorrow about actually putting your slides together because that's another important aspect of this. But for right now, make sure that you have focused on these points. Know how to calculate the total magnification. That's important. You want to know how to total magnification. Be familiar with the vocabulary eyepiece, objective lens, and the different powers. You also need to know the fine adjustment and the coarse adjustment. Knowing the base and the arm is important for carrying our microscope around the room. So the microscope lab is a really fun one, and I look forward to doing that tomorrow.